Hi all, today we are going to see Introduction to AC bridges. So as part of this we are going to discuss the derivation for the equation for balance and what is the condition you have to satisfy whenever you are going for the AC bridges for the coming lectures. So these bridge circuits are extensively used for measuring the resistance, inductance, capacitance, storage factor, loss factor, etc. of the components with so much accuracy. So the major advantage of this bridge type circuit will be it will have a bridge like this having 4 impedances, that means 4 branches will be there, and it will be supplied from a source in the 2 junctions, and remaining 2 junctions, across the remaining 2 junctions one detector will be connected. So this detector should show the 0 reading, so that in that condition we tell that the bridge is balanced. That means you will vary the component values in such a way that the detector will show the null reading. We are going to see the derivation and other things. First let us see what are the advantages of the bridge circuits, then we will go for the proof of the statements what we have discussed. So the bridge circuit merely compares the value of the unknown component with that of an accurately known component. So we are measuring this in terms of the known components. So the readout of this comparison is based on null indication at the bridge balance, and hence it is independent of the null detector. Because any type of instruments I have discussed, we have already seen in previous lecture, it will have some error and it will have so many issues. So as this is based on the null detection, all those disadvantages are removed here. So accuracy will be much more high, and the magnitude of the input voltage or its source impedance. So it will be completely independent of the null detector characteristics as well as the magnitude of where the input voltage and its source impedance. So irrespective of what magnitude of your input voltage you are giving, even this under balance condition, the equation will be independent of those voltages also. So because of this, the interchange of the source and the detector does not affect the balance conditions. Or we can tell this measurement accuracy is directly related to accuracy of the bridge components and not on the null detector or the source used. That is the advantage of this one. That means the disadvantage of other indicating type of instruments are not there in the case of null detection techniques. So that's why this we get the more accurate results when compared to normal measurements. So based on the type of the source excitation used, these bridges are broadly classified into 2 categories. One is a DC bridge and the second one is AC bridge. So it is called DC bridge if the voltage used for excitation is DC voltage, and these DC bridges are used for measurement of resistance, which we are going to discuss in the next module. And in this module we are discussing about the AC bridge. Yes, so here AC voltage is used for excitation and these are used for measurement of inductance, capacitance, storage factor, loss factor, frequency, etc. We are going to see one by one in detail in coming sections. So depending on which type of sources are used, because we are discussing about the AC type of bridges, so AC source is used. So the sources can be again classified into 2 categories. It can be either low frequency or high frequency. For the low frequency, generally the power line is used as your source. Power line means your 50 Hz supply source will be used as your source. And second case is high frequency. So in order to get the other than the supply frequency, we use electronic oscillators. So these electronic oscillators generally produce the frequency between 40 Hz to 125 kHz, and they are rated up to 7 watts of power. And the advantage of electronic oscillators is the frequency can be changed accurately. That means whatever exact frequency can be tuned, and second one, the waveform that is obtained will be very close to the sine wave. That means harmonics will not be there in your waveform, so that does not have any effect on your detector, null detector which is used. So for normally for ordinary AC bridge measurements of inductance and capacitance, a fixed frequency oscillator of 1000 Hz is used in practice, and generally the power rating of 1 watt is sufficient. Only in some specific cases which we are going to discuss in coming lectures, where we may need the variable frequency or high frequency supply, so generally 1000 Hz is used. So now coming to the detectors or the null detector which are used for detecting the balance. So these are the 3 commonly used methods. First one is the headphones. The headphones are used for frequency range of 250 Hz up to 4 kHz, and they are very much sensitive in this range. So headphones will be used, they will be connected to the ear and we will hear the sound. When the sound becomes 0, that means it is null value. That means it is under balance condition. And the second type of detector is vibration galvanometers. Generally, vibration galvanometers are more sensitive for power and audio frequency range. That means up to 200 Hz, vibration galvanometers are more sensitive when compared to headphones. So that's why these are vibration galvanometers are used for normally for power and audio frequency ranges. And the third one is tunable amplifier detectors. So there will be a tunable amplifier, along with that one detector or indicator also will be there. So these are used for a frequency range of 10 Hz to 100 kHz. So out of these three techniques, this third one is the more versatile detector. And the second advantage of this one is, in this case we will use the transistor amplifier can be tuned electronically and then can be made to respond to a narrow bandwidth. That means it will be immune to the harmonics that are produced in your system. So we can tune to the particular frequency depending on what is the source frequency you have used. So only for that frequency component it will respond. We can tune to only that particular frequency component. And second advantage, we can fine tune when compared to other two methods. We can fine tune for a particular frequency. That is the advantage of this one. So in this case, what happens, one amplifier will be there which will be fine tuned to a particular frequency. Only that particular frequency output will be fed to a pointer type of instruments. So pointer type of instruments will show the reading. So when the reading shown is equal to 0, that means there is a null or the balance is obtained. So in practice, generally these tunable amplifiers are used in combination with the headphones. That means both headphones as well as tunable amplifiers are used for detecting the balance condition. So let us now try to derive the equation for the bridge balance, and we will through all the statements what we have discussed before. That means under balance condition it is independent of the type of the detector used and is independent of type of the source used. So we are going to derive that one. So under balance condition, you can see this is the bridge. Let us assume this is my point A. This is the junction, this is B, C and D. The currents that are passing here, let us assume out of the total supply current that is given. So let us assume this is the current taken from the supply. This will divide into I1, I2. So once this reaches this junction, let us assume some current is passing through the detector. Remaining current will pass through this Z3. So similar is the case, I2 is coming here. This ID is coming here, both the currents are reading. So I4 will be sum of I2 plus ID that will reach the point T. So in this way they will pass. So under balanced condition, because the detector should show the 0 reading, that means the current passing through the detector will be 0 under balanced condition. That means when ID is equal to 0, we can tell the value of I1 will be equal to I3. Similarly, I2 will be equal to I4. Or otherwise, we can tell that the current passing through the detector will be 0 only when the potential between this point B and C is equal to 0. That means there is no voltage difference between these 2 points. So that's why the current passing through this detector is equal to 0. Because current passing through any branch is equal to potential difference across the two ends divided by impedance of that particular resistor or particular component. So it is independent of the impedance of this component. If the voltage is equal to 0, automatically current will be equal to 0. So the same thing I am mentioning here, that is the potential difference between points B and D is 0. What is the meaning of potential difference between these 2 points is 0? So whatever is the voltage here, same voltage is here, or with respect to what from A to B, whatever voltage is dropping, same voltage will drop between A to C, because A is at supply potential. Let us assume this side is plus, this side is minus. It is at supply potential. So whatever is the voltage drop here, same voltage drop is here. That means voltage of B will be equal to voltage of C. So if you have the doubt about how to design this bridge circuit, how to calculate the components and other things, you can please refer to basic electrical engineering playlist. So there I have explained in the DC circuits what will be the case of the bridge and how to analyze these things. So you can please refer there. So there I have explained in detail. I hope that you already have the basic idea. So I am proceeding further. So the value of E1 will be equal to E2. This is the first condition, and obviously the value of E3 will be equal to E4, obviously because this value also will be same. So E3 will be equal to E4, or from this E1 is equal to E2. So from this I can write as I1 multiplied by Z1 will be equal to I2 multiplied by Z2. Let us take it as equation number 1. So also as the value of the deflector current ID is equal to 0. So obviously I have discussed the value of I1 will be equal to I3 will be equal to. So what will be the value of I1 and I3? So the current, because in this parallel path you can see it is connected between points A and D. That means the current passing through this one, I1 is equal to I3 is equal to voltage between the points A and D divided by the total impedance. Because this is now removed, because ID is equal to 0, you can remove this detector. So this will be equal to, because between A and D is nothing but your supply voltage, this is E divided by Z1 plus Z3. Getting it? So similar, same thing I am writing here, E divided by Z1 plus Z3. So this I am taking as equation number 2, and similarly I can write I2 is equal to I4 is equal to same way E divided by, in the second branch what are there, Z2 and Z4 are there. So this will be equal to Z2 plus Z4. So let us take them as a vectors, because current is a vector, to avoid the confusion. So to avoid the confusion I am taking all as the vectors. So E1 is equal to E2. Sorry, or we can call in AC circuit, we call them as phasors instead of vectors. So this is the value. So this I am taking as equation number 3. So now what I am doing, substituting equation number 2 and equation number 3, I am substituting in equation number 1. So what is equation number 1? I1 multiplied by Z1. So what is I1 from this equation number 2? This is nothing but E divided by Z1 plus Z3. So that is I1 multiplied by Z1 is equal to I2. I2 from here will be E divided by Z2 plus Z4. So this I have to multiply with Z2. Getting this one, E is common in both the sides, we can cancel it. So the remaining components are there. So I am just cross multiplying this. Z1 plus Z3 I am taking this side, Z2 plus Z4 I am taking this side. So this I can write in the form Z1 multiplied by Z2 plus Z1 multiplied by Z4. This will be equal to Z2 multiplied by Z1 plus Z2 multiplied by Z3. Again you can see here Z1 Z2 and Z1 Z2 are same in both the sides. You can cancel it. So under balanced condition we got the equation as Z1 multiplied by Z4 will be equal to Z2 multiplied by Z3. Z1 multiplied by Z4 is equal to Z2 multiplied by Z3. So this I can write as equation number 4. Or sometimes what happens, they will be represented in terms of admittances, or so we can write it in terms of the admittances as Y1 multiplied by Y4 will be equal to Y2 multiplied by Y3. So this I am taking as equation number 5, where the value of Y is equal to 1 by Z. So I can replace the Z by admittances, because sometime when you are taking the parallel combination of anything, it will be easy to analyze using the admittances. Again, regarding the admittances, how to convert and how to do these things, these are again discussed in basic electrical engineering. You can please refer there. So I have discussed in basic electrical engineering all these details. So from this we can conclude, or we can observe from here. So if you are taking this bridge, so we got it as Z1 multiplied by Z4 is equal to Z2 multiplied by Z3. Z2 multiplied by Z3, same thing I have reproduced here. So you can see here I am taking the product of the adjacent opposite sides. So you can see this is my detector. Product of this impedance multiplied by the opposite band to this one Z4 will be equal to Z2 multiplied by Z3. That means the product of impedances of one pair of opposite arms must be equal to the product of impedances of the other pair of the arms. That means whenever the bridge is there, you need not derive it again. What you have to compare? So you are taking this detector as your reference. So take any one impedance, multiply with the opposite side one. So Z1 multiplied by Z4 should be equal to Z2 multiplied by Z3. So you remember here these are the phasors. So it will have both magnitude as well as angle, or it will have real as well as imaginary component, depending on which form you are representing. Again, this polar and rectangular form also discussed in basic electrical engineering. I hope you have the clarity of this. So if I am representing these impedances, I can represent this as Z1 at an angle of theta 1, Z4 I can write as Z4 at an angle of theta 4 is equal to, second side is Z2 Z3, so it is Z2 at an angle of theta 2, Z3 at an angle of theta 3. So remember here the theta can be positive or negative. It depends on whether it is inductive or the capacitive. So if you are taking this, because in polar form if you are multiplying two things, so the magnitudes will be multiplied and angles will add to each other. So that's why it will be Z1 multiplied by Z4 at an angle of theta 1 plus theta 4, and this side it will be Z2 multiplied by Z3 at an angle of theta 2 plus theta 3. So they will add to each other. So why they are adding to each other and these things, these also discussed in basic electrical engineering. You can please refer there if you don't have the idea about these basics. So now comparing the magnitudes and angles on both sides. So you can compare the magnitudes here. Z1 Z4 is equal to Z2 Z3. That is one condition, and second condition is theta 1 plus theta 4 is equal to theta 2 plus theta 3. You can see that you are getting two equations, both the equations should be satisfied. That means both the magnitude and phase angle must be satisfied. Let us see in other system, that means rectangular coordinates. So if I am representing in rectangular coordinates, I can represent Z1 is equal to R1 plus JX1. Similarly, Z4 is R4 plus JX4. Similarly, Z2 is R2 plus JX2 and Z3 is R3 plus JX3. So I am separating the real and imaginary component. So real component will be R1 multiplied by R4. Then J multiplied by J is J square. J square is nothing but minus 1. So that's why it will become minus X1 multiplied by X4. Plus imaginary component will be J of X1 multiplied by R4, and similarly this X4 multiplied by R1. So I have written here. Similar is the case this side also, R2 into R3 minus X2 into X3, because J square is equal to minus 1, plus J R3 X2 and X3 R2. So same thing I have written here. This let us take as equation number 9. Again same thing, this I can compare the equation on both sides, that means real components and imaginary components. So real components R1 R4 minus X1 X4 will be equal to R2 R3 minus X2 X3. Similarly, imaginary component X1 R4 plus X4 R1 is equal to X2 R3 plus X3 R2. So again, no need to mug up these equations. We can derive easily at that instant only. Only you should know the concept. So main thing is the concept required. Remaining things you can derive easily in the exam. No need to mug up any formula. So both the independent conditions, that means 11 and 12 should be satisfied. So from the above two things we have observed that whenever you are solving the bridge circuit under balanced condition, you will get two equations for AC bridges. So we have to solve the two equations. The same thing I have mentioned here, general form of the AC bridge. Two balance equations are always obtained for the AC bridge circuit, because under balanced condition both magnitude and phase, if you are representing in polar form or if you are representing in rectangular form, real and imaginary components must be equal. So that's why two equations will come. So as the two equations are obtained, so we can solve for two unknowns, because two equations means we can solve up to two unknown quantities. So we can solve up to two unknown quantities using this bridge in balance condition. So on the third one which should be satisfied is the variables that are varied for obtaining the balance should be independent to each other. So this statement will be confusing. Let us take one example. So let us take for example, I don't know the value of R1 and L1. I want to find the value of R1 and L1. So detect this. Let us assume I have kept a circuit here R2, L2, R3 and R4. So here these are pure resistors and two impedances are there. So let us take for example to make the analysis or understand the concept only. So under balance condition we know product of the opposite branch impedances will be same. That means Z1 multiplied by Z4 will be equal to Z2 multiplied by Z3. Agree with me? So what is Z1? Z1 is R1 plus J omega L1 and Z4 is R4. I am representing in rectangular form. And second one R2 plus J omega L2 will be, this will be multiplied with R3. So R3 is there. So now this I can expand as R1 R4 plus J omega L1 into R4 is equal to R2 R3 plus J omega L2 into R3. Or from this I can write R1 R4 and this side it is R2 R3. So real components I have compared. R1 R4 is equal to R2 R3 because the unknown values of R1 and L1. So from this I can write my value of R1 is equal to R2 R3 by R4. So similarly, comparing the imaginary terms, I will get it as omega L1 R4, or omega is same in for both. So omega I have cancelled. L1 R4 is equal to L2 R3. Or from this I can write L1 is equal to L2 multiplied by R3 by R4. L1 is equal to L2 multiplied by R3 by R4. So you will get the doubt why I have taken the constant resistors here, why not some capacitor or why some other components. You can see here because I have taken like this. So that's why you can see in all the equations there is no term of frequency. That means these equations are independent of the frequency. That means they are not affected by any type of harmonic components or the frequency components. So that is the advantage of designing the circuit like this. So while designing the circuit, we have to take care that the equations as far as possible should be independent of the frequency. So that's why different bridges came into existence. So that we are going to see the details in the coming lectures. So now from these equations you can see here, in order to obtain R1, it is R2 into R3 by R4. This is L2 into R3 by R4. So R3, R4 are common to both the equations. Let us assume if you take R3 and R4 are the variables, or R3 or R4 are the variable, then as they are in the both the equations, when you vary, both the equations are disturbed. So getting the balance will be very difficult task. So that's why in practice we have to select the variables which are varied in such a way that they will appear in only one equation. That means when you vary that particular component, only one equation will be affected, not the second equation. That means both equations will be independent of each other. So in this case you can see R2 is appearing only in equation number 1 and L2 is appearing only in equation number 2. That's why this R2 and L2 are taken as the variables for balance. So how we will do it? We will vary either R1 or L1 first, so that the detector value, whatever value it is showing, will decrease. Then vary the second one, like that one after the other they are finely tuned until we get the balance. So in that way getting the balance will be easy. So instead of taking this R2 and L2, let us assume if I take R3 and R4, then in that case the tuning will be very difficult task. Getting the balance will be very difficult task, because when you vary the value, it will disturb both the equations. So that's why it will be very complex. So that's why practically whenever you are designing any bridge circuit, the variable should be taken such that they will appear in only one equation, and second one, as far as possible the equation should be independent of the frequency. That means you have to select the bridge remaining components in such a way that whatever equation comes, it will come as independent of the frequency. Like for example, in this case R1, L1 is fixed, we cannot change it, because I want to find the value of the inductance. We know practically every inductor will have some series resistance, also practically every choke will have some resistance. So in order to find these values, so how can I design in such a way it will be no frequency term will come. So in that way we have to design. I hope the basic concept of the AC bridges, what care should be taken while designing any bridge is clear to you. So next class onwards we are going to start the how to find the value of the inductance first. Once it is over, then we will go for the capacitance, then we will go for how to find the other parameters, so and followed by the other things. So I hope everything is clear up to now. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you very much.